electric circuits and measurements and instrumentation paper. Analog circuits are the basics of this electrical and electronic measurements paper. This electrical and electronic measurement papers is one of the simple paper to score good marks in the gate paper. Okay, this deals with a very simple basic questions. So we will move on to the question session. In the last class, we have discussed almost 20 gate questions with the combination of both 1 mark and 2 mark questions. So in the same way, in today also we are going to discuss the questions with the answer. Okay, what are the topics are under the syllabus of electrical and electronic measurements? We know that in the last class itself I have mentioned these are the topics comes under the heading electrical and electronic measurements. All the topics are from electric circuits as well as the measurements and instrumentation paper only. We know bridges and potentiometer, measurement of voltage, current, power, energy and power factor, instrument transformers, digital voltmeter, multimeter, the measurement of phase, time and frequency measurement, oscilloscopes, CRO and DSO oscilloscopes, error analysis. These are comes under the heading of electrical and electronic measurements paper. So we can score good marks in this paper. This is one of the simple paper which we can give a little bit concentration to get good score. We no need to take much effort to score good marks in the electrical and electronic measurement. If you want to, if you aim for a gate score, definitely you can concentrate and you can score good marks in this paper compared to a tough paper like control systems or signals and system like that. Compared to those papers, this is a simple paper. Definitely you can get 5 out of 5 in this paper. Okay, let's move on to our question and answer session. Okay, see, this is one of the question. This can anyone say this comes under which topic in the syllabus? These are the topics comes under the syllabus of electrical and electronic measurements. Now I will read the question. You have to specify at which topic under which topic this question comes. Okay, the probes of non-isolated two-channel oscilloscopes are clipped to points A, B, and C in the circuit of the adjacent figure. V in is a square wave of a suitable low frequency. The display on channel 1 and channel 2, CH1 and CH2, are as shown on the right. Then the signal and ground probes, that is S1, G1 and S2, G2 of channel 1 and channel 2, respectively, are connected to points. The question comes under which topic in the syllabus? Can anyone say? Can anyone specify this question comes? Under which topic this question comes? Can anyone specify? These are the topics in the syllabus of electrical and electronic measurements, right? This is the question. Can anyone say under which topic this question comes? Yes, good. This comes under oscilloscope. Oscilloscopes, both CRO, DSO, that are comes under the oscilloscope. This is one of the very good umbrella one. This is also comes under that oscilloscope topic. So the probes of non-isolated two-channel oscilloscopes are clipped to points A, B, and C in the circuit of adjacent figure. This figure, it comes under this figure. I will go use the pointer. Can anyone try this? Can anyone try this? This is a connecting point A, B, and C. The input voltage V in is a square wave with a suitable low frequency is given as an input. The display on channel 1 is this, channel 2 is this. Then the signal and ground probes S1 G1 and S2 G2 of channel 1 and channel 2 are respectively connected to the points. Can anyone try this? The options are A, B, C, A. The channel 1 S1 is first is S1 G1 is connected to A, B. S2 G2 is connected to C, A. The option number 2 A, B, C, B. The option number C, C, B, A, B. The option number D, B, A, B, C. Can anyone try this? Can anyone try this? Can anyone try this? What you infer from this output of channel 1 and channel 2? Is there any difference in the output of channel 1 and channel 2? Is there any difference in the output of channel 1 and channel 2? Is there any difference? The channel 1 and channel 2 output are look similar. Channel 1 output is similar to channel 2. Channel 2 is similar to channel 1. So there is no difference between the output of channel 1 and channel 2. Channel 1, consider channel 1 output is the voltage across resistance and channel 2 output is the voltage across inductance. This is channel 1 and this is channel 2. See, the both resistor and inductor has a common point B. So if both the outputs are similar, then the common point, what is the common point in both the channels? What is the common point in both the channels? What is the common point in both the channels? Can anyone say? The common point in both the channel is ground point. S1 is signal point, G1 is ground, S2 is signal 2 and G2 is ground. So the common point is ground. So the common point between resistor and inductor is B. The common point between the output is ground. So always the B point is the ground. Always B point is the ground. So there's a chance of options between B and C. There's a yes, common good. Common point is ground. So the options should contain two B points. So options between B and C. See, resistance, this channel 1, A and B. Since both the waveform appeared across resistor and inductor, we know that both the waveform appeared across resistor and inductor are same. So the common point is B. So we are taking signal probe S1 is connected to A, signal probe S2 is connected to C. Both the ground probes G1 and G2 are connected to common point B. If we consider this consideration, what will be the answer? If we consider this consideration, what will be the answer? The answer is the S1 G1 is connected across A and B. S2 G2 is connected across C and B. So the answer is option B. B is the common point between both the channels. B is the common point between both the channels. If I consider B is the common point between both the channels, the output across resistor is taken between A and B. The output across inductance is taken across C and B. B is the common ground point. Can you understand this? Can you understand this question? Can you understand this, ma? Say yes or no. Can you understand how the answer comes option B? Say yes or no. Okay. I'm moving on to the next question. The next question is, a bridge circuit is shown in figure below. A bridge circuit is shown in the figure below. Which one of the sequence given below is most suitable for balancing the bridge? A bridge circuit is shown in the figure below. Which one of the following sequence given below is the most suitable for balancing the bridge condition? Okay. What is the condition for balancing the bridge? Can anyone say what is the condition for balancing the bridge? What is the condition for balancing the bridge? What is the condition for balancing the bridge? What is the condition for balancing the bridge, ma? They have given the 4 options. What will be the best option to balance the bridge? That is the question. They have given a bridge circuit. They are asking which of the following sequence will be the best suitable for balancing the bridge. What is the balancing condition for bridge? What is the condition for balancing the bridge? Just try it. What is the condition for balancing the bridge? Can anyone say what is the condition for balancing the bridge? What is the condition for balancing the bridge? Usually we have the formula Z1, Z4 equal to Z2, Z3. Z1 is the opposite poles impedance. The product of opposite impedances is balancing the bridge condition. Z1, Z4 equal to Z2, Z3. Which one of the following in the given option, which one is the best to balance the bridge? The option 1 is first adjust R4 and then adjust R1. The second is first adjust R2 and then adjust R3. The third is first adjust R2 and then adjust R4. The fourth one is first adjust R4 and then adjust R2. What will be the answer? What will be the answer? We know that to balance the bridge, Z1, Z4 equal to Z2, Z3. In the given condition, Z1 value is equal to R1 plus JX1. Z4 is equal to R4 minus JX4. Z1 value is R1 minus R1 plus JX1 because it is inductance. Z4 value is R4 minus JX4 equal to Z2, Z3. Z2 value is equal to R2. Z3 value is equal to R3. So balancing bridge condition, we know Z1, Z4 equal to Z2, Z3. So R1 plus JX1 equal to R4 minus JX4 equal to R2, R3. So just a product. By simplifying this equation, I am getting R1, R4 plus X1, X4 equal to R2, R3. R1, R4 plus X1, X4 equal to R2, R3. By simplifying this, I am having x1 r4 minus r1 x4 equal to 0, which will become x1 by x4 equal to r1 by r4. R1 is in the denominator, r4 is in the numerator. So it is best to adjust the R4 first and then R1. This is the answer, option A. Option A is the correct answer. First to balance this bridge, first we have to adjust R4 and then we have to adjust the value of R1. This is the option A. Option A is the correct answer. Can you understand? I'm just applying the condition for balancing the bridges. The condition for balancing bridges, we know that in case of impedances, Z1, Z4 equal to Z2, Z3. Here Z1 value is R1 minus JX1, sorry, R1 plus JX1. Z4 value is R4 minus JX4. So R1 plus JX1 into R4 minus JX4 equal to R2, R3. By simplifying that, I am getting x1 by x4 equal to r1 by r4. R4 is in the denominator, r1 is in the numerator. It is always to adjust the denominator first and the numerator second. So to balance the bridge, I have to adjust the r4 value first and then I can adjust the r1. Can you get my point? Can you get my point? Can you understand, ma? Say yes or no. Say yes or no, ma. Nobody is listening. I'm not receiving any responses. Can you understand how to solve this problem? How to get the answer for this question? Can you understand, ma? Can you understand how to get the answer for this question? The answer is first I have to adjust R4 and then I have to adjust R1. Can you get my point? Okay, I'm moving on to the next question. The time division and voltage division. The time division and voltage division axis of time for divisions and voltage per division axis of an oscilloscope have been erased. The time per division and voltage per division axis of an oscilloscope have been erased. A student connects 1 kilohertz 5 volt peak to peak square wave. A student connects 1 kilohertz 5 volt peak to peak square wave calibration pulse to channel 1 of the scope. Channel 1 of the scope, and observe the screen to be shown in the upper trace of the figure. And observe the screen to be shown in the upper trace of the figure. An unknown signal is connected to channel 2 in the lower trace. Okay, this square wave is shown in the upper trace. This triangular wave is shown in the lower trace. An unknown signal is connected to channel 2 lower trace of the scope. If the time per division and voltage per division on both channels are the same, the amplitude and the peak to peak amplitude, the amplitude and period of the unknown signal are respectively. Can anyone say how to? This is a simple basic question with CRO. A simple basic question with CRO. You can try it. You can try to answer this question. The question is the time per division and voltage per division axis of an oscilloscope have been erased. A student connects a 1 kilohertz 5 volt peak to peak square wave calibration pulse to channel 1 of the scope and observes the screen to be as shown in the upper trace of the figure. An unknown signal is connected to channel 2 of the scope at the lower trace. If the time per division and voltage per division on both the channels are same, the amplitude and period of the unknown signal are respectively. You can try this. You can try this, ma. They have given the voltage value and frequency value of the upper trace. The upper trace peak to peak voltage value is the upper trace peak to peak voltage value is the upper trace peak to peak voltage value is for the square wave. For square wave upper trace peak to peak voltage value is 5 volt. The frequency is 1 kilohertz. The time value will be, if frequency is 1 kilohertz, what will be the time? What's the relation between time and frequency? What's the relation between time and frequency? What's the relation between time and frequency? I am asking a simple basic question. Yes, F is equal to 1 by T. Here T is equal to 1 by F. From the frequency is given, from the given frequency, we can calculate the time. So, for the upper trace, for the square wave, I am having the voltage value as well as the frequency value. Okay. The voltage value consists of two divisions, right? The voltage value consists of two division. The voltage value consists of two division. The time value, one full cycle consists of how many divisions? The voltage value, the peak to peak voltage value consists of two division. 1, 2. Two divisions. The peak to peak voltage value have two divisions. What about the time division? One full cycle consists of how many divisions? One full cycle consists of how many divisions, ma? One full cycle consists of how many divisions? I have highlighted that in the screen. Can anyone say? One full cycle of one full cycle consists of how many division? Time divisions. Time division 1, 2, 3, 4. It has 2 voltage divisions and 4 time divisions. Am I right? Am I right? Am I right? Am I right? In the same way, this channel 2, the output of the channel 2 consists of, one full cycle consists of 8 divisions. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Totally it consists of 8 time divisions. 8 time division. The channel 2 consists of 8 time division and the peak to peak voltage consists of 5 voltage division. See the first channel, channel 1. This is the channel 1. The channel 1 peak to peak voltage value is 5. It has 2 division. So voltage per division is 5 divided by 2, 2.5 volts. The same way, the time per division, to calculate the time per division, I am using the formula T is equal to 1 by F. By substituting this T is equal to 1 by F, that is 1 kilohertz. From this 1 kilohertz, I am having the value of 1 millisecond. The time value is 1 millisecond. The time division here is 4. 1, 2, 3, 4. The time division here is 4. So the time division is 1 by 4 millisecond. The voltage, each voltage division is 2.5 volt. Each time division is 1 by 4 millisecond. In the same way, for the lower trace, this triangular wave, the total peak to peak value consists of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The peak to peak value consists of 5 voltage division and 8 current division. So each voltage division consists of a voltage of 2.5 volt. So total voltage will be del V into 5. Del V into 5. So 2.5 into 5, it is 7.5 volt. It is 7.5 volt. The total time period is 8 divisions. Each division has a 1/4 millisecond. So 1/4 into 8, the time value is, time period is 2 millisecond. The voltage, peak to peak voltage value is 7.5 volt. Can you get my point? Can you get my point, ma? Can you understand? Can you understand how to get the answer for this problem? Say yes or no. Yes. This is a simple problem. You can answer within a minute. You can answer within a minute. I am trying to explain with the help of simple techniques only. Okay. Shall I move to next question? Okay, I am moving on to the next question. This also gives the same. A sampling wattmeter. Okay, a sampling wattmeter that computes power from simultaneously sampled values of voltage and current. A sampling wattmeter is nothing but a meter that computes the power from simultaneously sampled values of voltage and current. Is used to measure the average power of a load. The peak to peak voltage of a square wave is 10 volt and the current is triangular wave of 5 ampere peak to peak as shown in figure. This is the value of voltage. The picture 1 is the value of voltage and the picture 2 is value of current. The total period is 20 millisecond. The period is 20 millisecond. The reading in wattmeter will be. How can we calculate? Can anyone state the formula? Can anyone state the formula for power? What is the formula for power? Here we have the value of voltage as well as current, right? This is the voltage value and this will be a current value. What is the formula for power? Yeah, we know that power is equal to VI. P is equal to VI in a DC circuit. In AC circuits, what is the formula for power? In AC circuit, what is the formula for power? In AC circuit, the formula for power P is equal to 1 by T integral of 0 to T VI dt. Am I right? Power value is equal to VI. P is equal to VI in DC circuit. In AC circuit, P is equal to 1 by T integral of 0 to T VI dt. Okay. This is the voltage. The voltage peak to peak value is 10 volt. This one is the current waveform. The current peak to peak value is 5 ampere. Okay. If I am considering a power, the formula for power is P is equal to 1 by T integral of 0 to T VI dt. This is the voltage waveform and this one is the current waveform. So if we consider this voltage and current waveform, there is no common area between voltage and current. There is no common area between this voltage and current. So the total V and I common area is 0. So output reading of a wattmeter will also be a 0. The output reading of a wattmeter will also be a 0. Can you understand, ma? Can you understand how the answer is 0? Can you understand why the answer is 0? Can you understand why the answer is 0? Say yes or no. There is no common point between this voltage and current. There is no common area of voltage and current, so automatically the answer, the power is a product of V and I. In the figure, there is no common area between voltage and current, so automatically the current power value will be 0. Okay. Next, the question is a current of minus 8 plus 6 root 2 sine omega t plus 30 degree. A current of minus 8 plus 6 root 2 sine omega t plus 30 degree ampere is passed through 3 meters. The 3 meters are, they are center 0 PMMC meter. Second one, a true RMS meter and a moving ion instrument. A current of minus 8 plus 6 root 2 sine omega t plus 30 degree ampere is passed through 3 meters. The 3 meters are center 0 PMMC meter, a true RMS meter and a moving ion instrument. The respective reading in ampere will be, the 3 meters measures the same current, but what will be the answers? Here 3 meters, 3 different meters, a PMMC meter, a true RMS meter and a moving ion instrument. These 3 meters measures the same current of value minus 8 plus 6 root 2 sine omega t plus 30 degree. If a 3 different meters measures the same current, what will be the answer? We know that a first meter is PMMC meter. PMMC meter measures AC or DC current. A PMMC meter measures DC or AC current. A PMMC meter will measure DC or AC current. A PMMC meter will measure DC or AC current. Yes. A PMMC instrument usually always reads a DC current only. So in this, the DC parameter is this minus 8. Okay, in this a DC parameter is minus 8. So the first PMMC instrument reads only DC value. So the current measured by PMMC meter is minus 8 ampere. The current measured by first meter PMMC center 0 PMMC meter is minus 8 ampere. The second meter is a true RMS meter. A true RMS meter always reads the RMS value. A true RMS meter always reads the RMS value. Okay. The formula for RMS value is IRMS equal to root of minus 8 the whole square plus 6 root 2 the whole square divided by 2. Okay. IRMS equal to root of minus 8 the whole square plus 6 root 2 the whole square divided by 2. By simplifying this, I can get the RMS value of current is 10 ampere. The PMMC meter measures only the DC value. So the first meter measures minus 8 ampere. A true RMS meter always measures the RMS current value only. So the calculation of RMS current is root of minus 8 the whole square plus 6 root 2 the whole square divided by 2, which is equal to 10 ampere. The moving ion instrument, the third instrument is moving ion instrument. The moving ion instrument also reads the RMS value of a current only. The moving ion instrument also reads the RMS value of current only. So the current read by the third instrument, moving ion instrument, is the same 10 ampere. The current read by the RMS moving ion instrument is also a RMS current. So that is also 10 ampere, not milliampere, it is 10 ampere. 10 ampere. So the answer will be, what is the answer? What's the answer, ma? What is the answer? Yeah, PMMC instrument always reads a DC value. So the answer is 8. The second meter, true RMS meter, always reads the RMS value. So the RMS value calculation is root of minus 8 the whole square plus 6 root 2 the whole square divided by 2. This 2 comes because of a RMS value. The simplification of this gives a 10 ampere. The moving ion instrument, the third instrument, also reads only the RMS value. So the RMS value, third instrument value also 10 ampere. So the total current reading by 3 meters respectively minus 8, 10, 10. So the answer is option C. So the answer is option C. The answer is option C. Shall I move to next one? Shall I move to next one? Okay. I am moving on to the next question. A variable error W. Okay, W is error. A variable error is related to 3 other variables. A variable error is related to 3 other variables X, Y, Z as W equal to XY by Z. A variable error W is related to 3 variables XY and Z as W is equal to XY divided by Z. The variables are measured with meters of accuracy. The X measured with plus or minus 0.5% reading. Y measured with plus or minus 1% of full scale reading, full scale value, and Z measured with plus or minus 1.5% of reading. என்னமா அம்பலவாணன் 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 unmute your mic ma. Sorry, mute your mic ma. அம்பலவாணன் mute your mic. Ambalavan, mute your mic, ma. Okay. See, a variable error W is related to three other variables X, Y, Z as W equal to XY by Z. The variables are measured with meters of accuracy plus or minus 0.5% reading or plus or minus 1% of full scale value and plus or minus 1.5% of reading. The actual readings of 3 meters are 80, 20 and 50. With 100 being the full scale value for all the three. With 100 being the full scale value for all the three. The maximum uncertainty in the measurement of error will be. The maximum uncertainty in the measurement of W will be. Options are plus or minus 0.5%, plus or minus 5.5%, plus or minus 6.7, plus or minus 7.0. The given relation is W is equal to XY divided by Z. The given relation is XY divided by Z. So in terms of logarithmic, I can write this as a log W equal to log X plus log Y minus log Z. We have to calculate the maximum uncertainty, that is error. The maximum error in W. The maximum percentage of maximum error, deviation. The deviation will be percentage of dW by W equal to plus or minus dx by x plus or minus dy by y plus or minus dz by z. Okay. So the dx by x value, the variation is given as a plus or minus 0.5% of reading. We know that. The second one, the deviation in y, dy by y is equal to plus or minus 1% of full scale value. Plus or minus 1% of full scale value. The full scale value is 100. We know that all the 3 meters has a full scale value of 100. So plus or minus 1% of full scale is plus or minus 1 by 100 into 100, which will be equal to plus or minus 1. The value measured by that deviation is 20. So plus or minus 1 divided by 20 into 100. To calculate that in percentage, I am multiplying that by 100. So the deviation is plus or minus 5%. For Z parameter, we know that the deviation is dz by z is equal to 1.5% reading. So the total deviation is dw by w. The total deviation dw by w equal to dx by x plus dy plus or minus dy by y plus or minus dz by z. So plus or minus 0.5 plus or minus 5% plus or minus 1.5%. The totally plus or minus 7%. That is the answer. Option D. Option D is the answer. Option D is the answer. Can you understand? Can you understand, ma? Can you understand, ma? Okay, I'm moving on to the next question. See, R1, R4 are the opposite arms on a Wheatstone bridge, as are R3 and R2. R1 and R4 are the opposite arms on a Wheatstone bridge, as are R3 and R2. The source voltage applied across R1 and R3. The source voltage is applied across R1 and R3. Under balanced condition, which one of the following is true? R1 and R4 are the opposite arms of a Wheatstone bridge, as are R3 and R2. The source voltage is applied across R1 and R3. Under balanced condition, which one of the following is true? Under the balanced condition, which one of the following is true? Option A, R1 equal to R3, R4 by R2. Option B, R1 equal to R2, R3 by R4. Option C, R1 equal to R2, R4 by R3. Option D, R1 is equal to R2 plus R3 plus R4. Can anyone say how to solve this question? Can anyone say how to solve this question? Can anyone say how to solve this question? What is the condition for balancing the bridge? What is the condition for balancing the bridge? What is the condition for balancing the bridge? What is the condition, ma? What is the bridge balancing condition? What is the bridge balancing condition? What is the condition for balancing the bridge? The condition for balancing the bridge is Z1, Z4 equal to Z1, Z4 equal to Z2, Z3. That is a balancing condition. Here the source voltage is applied across R1 and R3. The source voltage is applied across R1 and R3. This is the bridge consists of R1, R4 and R2, R3. The source voltage is applied across R1 and R3 during the balancing condition. During the balancing condition of the bridge balancing condition, the current through this galvanometer is the current through this arm CD. The current through arm CD is 0. Current through arm CD is 0. Current through arm CD is 0. So galvanometer value reads 0 during the balanced condition. So I am writing the node equation. I am writing the node equation. Node equation, we know that node equation at C and D. Node equation at, writing node equation at C and D. At C, I am writing VC minus. This is the voltage across VC. VC minus V divided by R1 plus VC by R3. For this node C, VC minus V divided by R1 plus VC by R3 equal to 0. From that equation, I can write VC equal to V into R3 divided by R1 plus R3. In the same way, I am applying node equation at node D. No D also I am taking the same V naught. V naught VC தான். Minus V minus VD. V minus VD divided by or VD minus V. VD minus V. VD minus V divided by R2 plus VD by R4 equal to 0. From these two equations, VC equal to V into R3 divided by R1 plus R3. VD equal to V into R4 divided by R2 plus R4. At the balanced condition, the current through arm CD is 0. So the voltage VC equal to VD. So I am having the value of VC. This is the value of VD. So I am having the equation VC equal to VD. V into R3 divided by R1 plus R3 equal to V into R4 divided by R2 plus R4. By simplifying the equations, I am getting R1 equal to R2 R3 divided by R4. R1 equal to R2 R3 divided by R4. This is option number. R1 equal to R2 R3 divided by R4. This is option B. The answer is option B. Can you understand? Can you understand, ma? Can you understand? Can you understand how to solve this problem? Just I am applying the bridge balancing condition. In the bridge balancing condition, at the balancing condition, there is no current through the arm CD, through the galvanometer. So automatically the voltage VC and voltage VD will be equal. To calculate the voltage VC and VD, we know that to calculate the voltage, we are applying current law. To calculate the voltage, we are applying the current law. So by applying current law, I will get by applying node equations KCL, I am getting the value of VC and VD. If the VC and VD values are, by equating VC and VD value, I am getting the relation R1 equal to R2 by R2 R3 by 4. Okay. Can you understand? Shall I move to next question? Can you understand? Shall I move to next question? Yes. Okay. This is a simple question. Answer question. The Q meter works on the principle of basic electric circuits that we used to study. In basic electric circuit, we have studied the concept of quality factor in which topic? The options are mutual inductance, self-inductance, series resonance, and parallel resonance. The Q meter works on the principle of option A, mutual inductance, option B, self-inductance, option C, series resonance, option D, parallel resonance. The answer is series resonance. Without taking much time, you can answer. The answer is series resonance because you have studied circuit analysis, electric circuit analysis paper in the second semester. In that paper, you have studied the quality factor concept in series resonance only. In the parallel resonance, you didn't studied any quality factor relationship. In series resonance only, you can get the formula for quality factor. So the Q meter, quality factor meter works on the principle of series resonance. Always keep this in mind. It works on the principle of series resonance only. We are having the series resonance circuit. The resonance circuit consists of RLC circuit with AC input. RLC circuit with AC input. Series RLC circuit with AC input is called as a series resonance circuit. In the series resonance circuit, the formula for quality factor is XL by R or XC by R. The quality factor concept. The quality factor concept is employed only in series resonance circuit only. In the series resonance circuit, the formula for quality factor is XL by R or XC by R. XL by R or XC by R is the formula for quality factor. Keep this in mind. Okay, I'm moving on to the next question. This is also a simple question. You can answer within a second. Okay, the second one is a PMMC voltmeter. A PMMC voltmeter is connected across a series combination of DC voltage source. A PMMC voltmeter is connected across a series combination of DC voltage source. V1 equal to 2 volt and it is connected and a AC voltage source of V2 of T equal to 3 sin 40. A PMMC voltmeter is connected across a series combination of DC voltage source V1 equal to 2 volt and AC voltage source V2 of T equal to 3 sin 4T volt. The meter read, the answer is, the meter read, we know that the PMMC meter always reads DC value only. இதுக்கு முன்னாடி ஒரு ப்ராப்ளம் in the previous one of the problems in the previous questions I have given one AC value. In that AC value is measured by the same value is measured by 3 different meter. The first meter is PMMC meter. So I have taken the assumption, taken the consideration. The PMMC meter always reads the respond ma. A PMMC meter always reads the PMMC meter always reads the PMMC meter always reads the yes, it always reads the DC value only. So it is, even though it is connected across a series combination of DC voltage V1 equal to 2 volt and AC voltage V2 of T equal to 3 sin 4T, a PMMC measure DC value only. So the answer is option A. It measures only DC value. So the answer is option A. I'm moving on to the next question. The next question. What is the next question? A digital to analog converter, a DAC, a digital to analog converter with a full scale output voltage of 3.5 volt has a resolution close to 14 millivolt. Has a resolution close to 14 millivolt. What is its bit size? What is its bit size? A digital to analog converter with a full scale output voltage of 3.5 volt has a resolution close to 14 millivolt. Its bit size is, we know the formula for resolution. The formula for resolution of n bit ADC. The formula for resolution of n bit ADC equal to full scale voltage divided by 2 power n minus 1. The resolution of n bit DAC. The resolution of n bit DAC formula is full scale voltage divided by 2 power n minus 1. N is nothing but bit size. N is nothing but bit size. So resolution of n bit DAC, here the resolution is 14 millivolt. They have given. So I am substituting the value of resolution 14 millivolt. The full scale voltage value is 3.5 volt. That is also given value. So 14 millivolt equal to 3.5 volt divided by 2 power n minus 1. I have to find the value of n, bit size. So 2 power n, I am bringing 2 power n minus 1 in the left hand side, remaining terms in the right hand side. So 2 power n minus 1 is equal to 3.5 divided by 14 into 10 power minus 3. 2 power n minus 1 equal to 3.5 divided by 14 into 10 power minus 3. Simplifying this, I am getting the value of 250. 2 power n minus 1 is equal to 250. 2 power n is equal to 251. 2 power n is equal to 251. Approximately n value will be 8 bit. N value is equal to 8 bit. Can you understand? The given a digital to analog converter with the full scale output voltage of 3.5 volt has a resolution close to 14 millivolt. What is its bit size? The given parameters are resolution 14 millivolt, full scale voltage 3.5 volt. The formula for resolution is equal to full scale voltage divided by 2 power n minus 1. Resolution value is equal to full scale divided by 2 power n minus 1. So 14 millivolt. 14 millivolt is equal to 3.5 volt divided by 2 power n minus 1. By substituting all the values, I am getting the n value as a 8 bit. So the answer is option B. The answer is option B. Can you understand? Can you understand, ma? Can you understand? Say yes or no. Yes. Okay. The next one. See, the simultaneous application of signals, x of t and y of t, the simultaneous application of signals x of t and y of t to the horizontal and vertical plates. A simultaneous application of signals x of t and y of t to the horizontal and vertical plates respectively of an oscilloscope. It produces a vertical figure of 8 display. It produces a vertical figure of 8 display. If P and Q are constant, consider if P and Q are constants and x of t equal to P sine 40 plus 30 degree, P sine 40 plus 30 degree, what is the value of y of t? Then y of t is equal to, what is the value of y of t? Okay. The simultaneous application of signals x of t and y of t to horizontal and vertical plates respectively of an oscilloscope. It produces vertical figure of 8 display if P and Q are constants and x of t equal to P sine 40 plus 30 degree, then y of t is equal to, what is the value? Okay. The answer is, we know in the previous case also, in the last class I have taught one ellipse to circle as well as the circle to ellipse oscilloscope output questions. Can you remember? I have taught one question with respect to oscilloscope output in which it moves from ellipse to circle as well as circle to ellipse. In that problem also, I have used the same formula Fy and F divided by Fx. Fy divided by Fx is equal to meeting points of horizontal tangents divided by meeting points of vertical tangents. The meeting point of horizontal tangents is only at 2 points it meeting. It meeting at only 2 points. But in vertical point, it meets at 4 points. The horizontal tangent meets at only 2 points. The vertical tangent meets at 4 points. So Fy horizontal divided by vertical, Fy divided by Fx equal to 2 by 4. 2 by 4. So Fy, the relationship Fy is equal to 1 by 2 Fx. 1 by 2 Fx. So the Fx is it is 1 by 2 Fx. So P sine 40 plus 30 degree divided by 2 will give sine 2t plus 15 degree. That is answer is option B. It is A divided by this divided by 2. So automatically the option will be, the answer will be option B. Can you understand? Can you understand what is the logic here? If the changes, if it change in shape in the x of t as well as in the y of t parameter, in the oscilloscope output, if it changes in shape or if it changes in the x of t, y of t parameter, a simple formula we are applying here is the ratio of two, Fy and Fx, Fy horizontal as well as vertical meeting points given here. Okay, I'm moving on to next question. The same model also I have taught in the last class also. A DC ammeter has a resistance of 0.1 meter. Its current range is 0 to 100 ampere. If the range is to be extended to 0 to 500 ampere, the meter required the following shunt resistor. Then the value of the shunt resistance to be connected to extend the range. In the last class, I have taught you, if I want to increase the range of a current, then the resistance will be connected in. If I want to extend the range of current, then the resistance value should be connected in series or parallel. If I want to extend the range of current, the resistance value should be added in series or parallel. If I want to extend the range of current, if I want to extend the range of current in a meter, if I want to extend the range of current in the meter, if I want to extend the range of current, the resistance should be added in series or parallel. If I want to extend the range of current, the resistance should be added in parallel. If I want to extend the range of voltage, if I want to extend the range of voltage, the resistance should be connected in. இதுக்காக ஆன்சர் பண்ணலாமே. Series. Yes. If I want to extend the voltage value, then the resistance should be connected in series. Good. So here they have given the resistance is connected in parallel to extend the range of current. We have to find what's the value of a resistance. We know the total current value is 500 ampere. Through this 0.1 ampere, the current value is 100 ampere. In the parallel, remaining 400 ampere current will be flowing through this shunt current. We know in the parallel resistance, in the parallel combination, the voltage value will be same. So here the voltage value is, we know V is equal to IR, I is equal to 100, R value is equal to 0.1. So the voltage value will be 10 volt. The voltage value will be 10 volt. The same 10 volt across this also. In this case, voltage is 10, The current value is, the total current is 500 ampere. The total current is 500 ampere. The current flowing through 0.1 is 100 ampere. The remaining current 400 ampere is flowing through this shunt resistance. I have to find the value of the shunt resistance. The voltage across shunt resistance is equal to the voltage across the 0.1. So the voltage is 10 volt and the current is 400 ampere. So R value, formula for R is equal to, formula for R is equal to, formula for R, the formula for R is equal to, in terms of Ohm's law, formula for R is equal to, yes, R is equal to V by I. Here R value is equal to 10, V value is equal to 400. By substituting this, the resistance value is 0.025 ohm. The 10 divided by 4 will give 0.400. 10 divided by 400 will give 0.025 ohm. That is the answer. The answer is option C. Okay. Can you understand? Can you understand this problem? Can you understand how to solve this problem? Yes. I am moving to next question. The next question is the setup in the figure. The setup shown in the figure. The setup shown in the figure is used to measure resistance R. The ammeter and voltmeter resistance are, ammeter resistance is 0.01 ohm and voltmeter resistance is 2000 ohm respectively. Their readings are 2 ampere and 180 volt respectively. Giving a measured resistance of 90 ohm, the percentage of error in the measurement. What is the percentage of error in the measurement? The setup shown in the figure. The setup shown in the figure is used to measure the resistance. The ammeter and voltmeter resistances are 0.01 ohm and 2000 ohm respectively. Their readings are 2 ampere and 180 volt respectively. Giving a measured resistance of 90 ohm, the percentage error in the measurement is. What's the answer? I am remodeling this circuit. I am remodeling this circuit. The ammeter resistance value is 0.02 ohm and the voltmeter resistance value is 2000 ohm. We know this is the circuit given here, R. The voltmeter, this one is voltmeter, this one is ammeter. Okay. The current is E divided by 2000. The current flowing through voltmeter. The current flowing through voltmeter is voltage in the voltmeter divided by resistance. Current I is equal to V by R. V divided by 2000. The voltage resistance of a voltmeter. The resistance of a voltmeter is, in the given data, it is 2000. In the given data, it is 2000. The E value is 180. So IV is equal to current flowing through the voltmeter equal to E divided by 2000. 180 divided by 2000. The current flowing through voltmeter is 0.09 ohm. The total current measured by ammeter. The total current measured by the ammeter is 2 ampere. The total current measured by the ammeter is 2 ampere. The current flowing through a resistance. The current flowing through a resistance is total current minus current flowing through a voltmeter. The current flowing through this resistance is total current minus the current flowing through a voltmeter. Total current is 2 ampere. Current flowing through voltmeter is 0.09 meter. So I value is equal to 1.91 volt. Okay. So R is equal to E divided by I. R is equal to E divided by I. We know resistance value is equal to E divided by I. The current voltage value. These two are connected. The voltmeter is connected parallel across this resistance. So the voltage value is same, 180. The current value, current flowing through resistance is 1.91. So the resistance value is 180 divided by 1.91, which is equal to 94.24. The resistance value measured by voltmeter and ammeter is 180 divided by 2. That is 90. Actual resistance value is 94.24. The resistance measured value is 90 ohm. So percentage of error will be R minus R naught divided by R naught into 100. Percentage. For calculating the percentage, I am taking 100. For calculating the error value, I am taking the 100 value. So R minus R naught divided by R naught. R value is 94.24. R naught value is 90, which is equal to 4.71 percentage. That is option D. Can you understand? Can you understand, ma? Ma, can you understand this? Can you understand? Yes. Okay. I am moving to next question. The next one is a 1000-volt DC supply. A 1000-volt DC supply has two one-core cables. A 1000-volt DC supply has two one-core cables as its positive and negative leads. A 1000-volt DC supply has two one-core cables as a positive and negative leads. Their insulation resistance to earth are 4 mega ohm and 6 mega ohm respectively. Their insulation resistance to earth are 4 mega ohm and 6 mega ohm respectively as shown in figure. A voltmeter with resistance 50 kilo ohm. A voltmeter with resistance 50 kilo ohm is used to measure the insulation of the cable. A voltmeter with resistance 50 kilo ohm is used to measure the insulation. When connected between positive core and earth, then voltmeter reads the value. What is the value? Option A 8 volt, option B 16 volt, option C 24 volt, option D 40 volt. Can you understand the question? Can you understand the question? A 1000-volt DC supply has two one-core cable which is connected between positive and negative leads. The insulation resistance of each cable is 4 mega ohm and 6 mega ohm respectively as shown in the figure. A voltmeter with resistance 50 kilo ohm is used to measure the insulation of the cable. When connected between the positive core and earth, the voltmeter reading will be. I am remodifying the given diagram. The voltmeter with 50 kilo ohm, right? A voltmeter with 50 kilo ohm resistance. That 50 kilometer resistance is connected parallel across 4 ohm. This is the 4 mega ohm insulation resistance of a voltmeter. Another one is 6 mega ohm. Okay, here it is connected across 4 mega ohm. I have to calculate the voltage across this. Voltage across this. For this, I am applying the voltage division rule. The voltage division rule is source voltage into particular resistance divided by total resistance. Here, particular resistance, the voltage across 50 kilo ohm. Here, not only the 50 kilo ohm, it is the parallel combination of voltage across the parallel combination of 50 kilo ohm and 4 mega ohm. First, I have to simplify this. So, the particular resistance is 50 kilo ohm as well as 4 mega ohm. The total resistance is 6 mega ohm plus 50 kilo ohm parallel 4 mega ohm. By substituting all the value, the voltage measured, the measured voltage value is 8.10 volt. The measured voltage value is 8.10 volt. The measured voltage value is 8.10 volt. Can you get my point? Can you get my point? Say yes or no. Yes. The next one is a simple question. Two wattmeters which are connected to measure the total power on a three-phase system. Two wattmeter method. Okay. 2 wattmeter method of power measurement. Remember the 2 wattmeter methods. 2 wattmeters which are connected to measure the total power on a three-phase system supplying a balanced load. A wattmeter 1 reads a power of 10.5 kilowatt. A wattmeter 1 reads a power of 10.5 kilowatt. The wattmeter 2 reads a power of minus 2.5 kilowatt respectively. The total power and the power factor. Just we are going to apply the formula. The total power of 2 wattmeter, just we have to add the two powers. That is total power. The total power is power measured by wattmeter 1 plus power measured by wattmeter 2. The power measured by wattmeter 1 is 10.5. The power measured by wattmeter 2 is minus 2.5. So 10.5 plus minus 2.5 will be 10.5 minus 2.5. It is 8 kilowatt. We know the formula for 8 kilowatt. So automatically option A and B will be neglected. Option B is the answer is between option C and D only. Next, we have to calculate the power factor. The formula for power factor. The formula for power factor in a 2 wattmeter method is power factor equal to root 3 W2 minus W1 divided by W2 plus W1. Here W2, P2 is minus 2.5, P1 is P1 is 10.5. So root 3 into minus 2.5 minus 10.5 divided by P2 plus P1 minus 2.5 plus 10.5. By simplifying this, I am getting theta value is equal to minus 70.43. The power factor is cos theta. So cos of minus 70.4. Cos of minus 70.43 will be 0.334. So the answer is option D. A simple power factor formula. 2 wattmeter method. Two formulas are we are applying. The next one. The next question. See, a DC potentiometer. A DC potentiometer is designed to measure up to about 2 volt. A DC potentiometer is designed to measure up to about 2 volt with a slide wire of 800 millimeter. A DC potentiometer is designed to measure up to about 2 volt with a slide wire of 800 millimeter. A standard cell of EM of 1.18 volt obtains a standard cell of EMF 1.18 volt obtains balance at 600 millimeter. A standard cell of EMF 1.18 volt obtains balance at 600 millimeter. A test cell is seen to obtain balance at 680 millimeter. The EMF of test cell is, what is the value of EMF of test cell? இதெல்லாம் simple formula which you have studied in 12th standard itself. In the 12th standard itself, you know, for the DC potentiometer, the EMF is proportional to length. So we know the relationship between EMF and length, E1 and E2 equal to L1 and L2. Here E1 value given, L1 value given, L2 value given. We have to calculate E2 value. So E1 by E2 equal to L1 by L2. E1 equal to 1.18 volt. L1 equal to 600 mm. E2 equal to, we have to find E2 value. L2 value equal to 680 millimeter. By substituting all the values in this equation, I will get E2 is equal to E1 into L2 by L1. E2 is equal to E1 into L2 by L1. Here the formula is wrong. L2 by L1. L2 value is 680 millimeter. L1 value is 600 millimeter. E1 value is 1.18. By substituting all this, E2 value will be 1.34 volt, which is option B. Can you understand? In the potentiometer, we know that the relation between EMF and length is direct proportional. For a DC potentiometer, E is proportional to L. If E1 is proportional to L1 and E2 is proportional to L2, the constant, to remove the proportionality, we will introduce a constant. The constant in both the cases will get cancelled. By cancelling the constant value, I will get the equation E1 by E2 is equal to L1 by L2. In the problem, E1 value, L1 value, L2 value are given. We have to find the E2 value. By substituting all the value, the E2 value calculated as 1.34 volt, which is nothing but the option B. Okay, and option B. Can you understand this problem? Shall I move to next one? Can you understand this problem? Shall I move to next one? Say yes or no, ma. Shall I move to next one? Shall I move to next problem? Shall I move to next problem? Say yes or no. Can you understand this? I am moving to next problem. The next problem is the circuit in the figure is used to measure the power consumed by the load. This is the wattmeter. A circuit in the figure is used to measure the power consumed by the load. The current coil and the voltage coil. The current coil and the voltage coil of the wattmeter have resistance of 0.02 ohm and 1000 ohm respectively. The current coil and the voltage coil of a wattmeter have 0.02 ohm and 1000 ohm resistances respectively. The measured power compared to the load power will be. Options are 0.4 percentage less, 0.2 percentage less, 0.2 percentage more, or 0.4 percentage more. For this, I am remodeling this circuit. The output voltage is 200 volt. This is the same. thing given here. 0.02 is the internal resistance of current coil. 1000 ohm is the resistance of a potential coil, that is voltage coil. Okay, we have to measure the power. The current in the current coil is 20 ampere. Okay, the current in the current coil is 20 ampere. The total current measured, the total current measured can be calculated using the total current I1. The total current can be measured using voltage division rule. The total current can be measured using voltage division rule. The voltage division rule 20 equal to I1 into opposite resistance divided by total resistance. So 1000 divided by 1000 plus 0.02. So I1 is equal to 20.004. That is also approximately equal to 20 ampere. Okay. The voltage value is, current value is 20 ampere approximately. The voltage value, the input voltage, the current is approximately same, 20 only. The voltage, this voltage V1 value is equal to this 200 voltage equal to V1 minus this drop. V1 minus this drop. So 200 equal to V1 minus 0.02 into 20 ampere, which will be 200.4. 200.4. The power measured, we know the formula for power. Power is equal to V into I. The V value is 200.4. The I value is 20. So the power measured is 4008 watts. 4008 watts. The load power is, the load current is 20 ampere. The load power voltage is 200. So load power is 20 into 200, 4000 watt. Actual load power is 4000 watt. The measured power is 4008 watt. The measured power is more than load power or less than load power? The measured power is more than load power or less than load power? Can you infer this? The measured power is more or less than load power? The measured power is more or less than load power? The measured power is more or less. The measured power is 4008 watts. The load power is 4000 watt. The measured power is more than load power. So the answer is between option C and D only. The answer is between option C and D only. Percentage of change. To calculate the percentage of change, I am applying the formula PM minus PL divided by PL. PM minus PL divided by PL. Measured power is 4008 minus 4000 divided by 4000. This the simplified form will get 0.2. The answer is 0.2 percentage more. The answer is option C. Can you understand this? Can you understand this problem? Can you understand this problem? Okay. Shall I move to next one? Can you understand this one, Ma? Shall I move to next one? Okay. I'm moving on to next question. A galvanometer. Okay. A galvanometer with a full scale current of 10 milliampere. A galvanometer with a full scale current of 10 milliampere has a resistance of 1000 ohm. The multiplying power, that is the ratio of measured current to galvanometer current. The multiplying power of 100 ohm shunt is connected with this galvanometer. What is the multiplying power? How it will multiply? We know the multiplying factor. What is the value of multiplying factor here? What is the value of multiplying factor? To calculate the multiplying factor, The ratio is I1 by I2 equal to RSH divided by RM. I1 by I2 equal to RSH divided by RM. The shunt resistance value is 100. The measured resistance value is 1000 ohm. Yeah, measured resistance value is 1000 ohm. So I1 by I2 equal to 1 by 10. I1 by I2 equal to 1 by 10. So I can relate I2 equal to 10 I1. So I can relate I2 equal to 10 I1. By substituting this, the total current I is equal to I1 plus I2. So I1 is I1, I2 equal to 10 I1, 11 I1 equal to I, N is equal to I divided by the multiplying factor, multiplying power. The ratio is I divided by I1, which is equal to 11. I divided by I1, which is equal to 11. Can you understand this, ma? Simple relation. I1 by the current flowing through this is I1, current flowing through this is I2. This I1 by I2 is the ratio of 100 divided by 1000. RSH divided by RM. 100 by 1000. I am substituting this value. I am having the relation of 11. Can you get this point? Can you get this point, ma? Can you understand how to solve this problem? Can you understand how to solve this problem? Can you understand how to solve this? Can you understand? Shall I move to next one? Yes. The same way here also. A CRO probe. A CRO probe has an impedance of 500 kilo ohm in parallel with the capacitance of 10 picofarad. A CRO probe here. This 2 CRO through probe. 2 CRO through probe. It has a resistance of 500 kilo ohm and capacitance of 10 picofarad. The probe is used to measure the voltage between. The probe is used to measure the voltage between P and Q. This is the point P. This will be Q. What is the value of measured voltage? What is the value of measured voltage? This is the input voltage. This is the input voltage. This is the output terminal. To calculate the voltage across output terminal, I am applying the simple voltage division rule. The CRO probe has the capacitance of 8 picofarad, right? 10 picofarad. Capacitance of 10 picofarad and resistance value is 500 kilo ohm. So the CRO probe has 500 kilo ohm and the capacitance value of 10 picofarad. So the capacitance value is 10 picofarad. So from the capacitance value, I have to calculate the XC value. We know the XC value is equal to 1 by j omega c. 1 by j omega c. Here omega is nothing but 2 pi f. 2 pi f. F value is given in the problem. The frequency value is 100 kilohertz. So the Xc value is 1 divided by 2 pi into 100 into 10 power 3 into capacity value is 10 picofarad. So 10 into 10 power minus 12. By simplifying this, Xc value is equal to J divided by minus J divided by. By simplifying this, the Xc value is minus J divided by 159. Values minus J divided by 159. To calculate the voltage at this CRO point, the voltage at point P. This is the point P and this one is point Q. To calculate the voltage across point P and Q. The voltage across P here is the same voltage at this point, these three are common point. So the voltage at this point is equal to the voltage at point P. So VP. I am applying Kirchhoff's current law, KCL at node P. This is take this as a node P. I am applying Kirchhoff's current law at this node point P. I will write VP minus 10 volt. Here input is 10 volt. VP minus 10 volt divided by 100 plus VP by 100 plus VP by 500 plus VP divided by minus J divided by 159. Okay, by substituting this all the value, I will calculate the value of VP. That VP value is equal to 4.38. That is the answer. The answer is option B, 4.37. Can you understand? A simple Kirchhoff's current law is applied here. Can you understand this? Can you understand this? Say yes or no. Can you understand how this is calculated? Sorry. If you have any doubts in the problem I have taught, you can ask me, ma. If you have any doubts, you can ask me. Almost I have covered the 80% of the questions asked from this topic, electrical and electronic measurements, ma. Can you understand all those questions? Students, if you have any doubts, you can ask me, ma.